Hey guys, in today's video I wanted to show you my glass filter. You might be asking yourself, what in the world is a glass filter? Well, it is just a big filter housing. This is it right here. And it's filled with crushed glass. And if you've ever heard of sand filters that they use on pools, it's basically the same thing, only I'm running crushed glass instead of coarse sand. And the reason I'm running crushed glass in it is because through my reading I found out that glass is a much more effective filtration media than sand is, because glass has a slight negative charge and it attracts dirt particles, so it ended up being an excellent candidate for this little device I built. I built this about a little over 2 years ago, and I've been using it extensively ever since. I was just using up too many filter cartridges on my vapor blaster, so I needed something that was a little bit more robust, that could handle a lot of debris from the process, and this is what I came up with. A little bit about this. This is a type of well casing here. I think that's 8-inch. I forget the exact dimensions now, but I think this is 8-inch well casing. Of course, steel plate, PVC, big block of PVC here, and then these are the thumb screws to keep everything, because it's under pressure, keeps everything fastened down. There's O-rings sandwiched in between here. This is my pressure gauge. That's self-explanatory. This is a in-air purging valve. It's a float setup that when the water gets up too high, it comes up here and activates a float. It doesn't let the water come out the top. So they use those a lot in furnace boilers. And there's other things here too, just your typical connections. A couple of quick disconnects here. T-strainer for when I'm doing backwashing. This is the inlet. Down there is the outlet. And an air valve stem, and of course, you know, your valves here to regulate volume. So really, it's simple in concept, but it was kind of involved building it. Here, I'll show you it in, not much to see here, but I'll show you it in action. I usually run it between 28 and 30 psi, and I have it rated for 50 psi. It could go higher, but it's really not necessary to run it that high. So anyways, in this video and the other video segments, I'm going to be showing you how I constructed this filter. It's just too much machine work and assembly for one video, so I had to break it up into smaller segments. Okay, now that you've seen the whole thing, let's get to making this thing, and I hope you enjoy it. I started by squaring up my PVC blocks and milling them to size. This particular block is going to be the bottom plate. I used a surface grinder to cut a flat on my grooving tool so it would lock in place in my boring head. This shows the cutting of the O-ring groove. An O-ring is a rubber ring that when compressed seals two surfaces. This is necessary to keep water from leaking out when the filter is under pressure. This is an actual piece of material that the filter body was cut from. I'm using it here as a crude ring gauge to make sure the body will fit properly in the O-ring groove. The boring head makes quick work of finishing a hole for the outlet. Later during assembly, a threaded bulkhead fitting will be placed in the hole that will allow pipes to be attached to the plate. In order to be able to add crushed glass to the filter housing, there needs to be an access hole in the top plate. I'm using the grooving tool to cut halfway through one side of the plate and then finish cutting through on the opposite side. The first side has already been cut. I'm using a 3/4 inch end mill to cut counterbores for the tie rod nuts. The counterbore is a recess used to conceal a fastener or other feature such as screw or bolt heads, rivets, etc. Later I had to add 4 more tie rods because I found out that the pressure was just way too much for these 4 alone to handle. The tie rod is the threaded rod I used to hold the top plate, body, and bottom plate together. They also put pressure on the O-rings to seal the whole assembly. And yes, another O-ring groove. This one will be used to seal the cover to the top plate. These are just some holes for the thumb screws to go through. The thumb screws will hold the cover down against the top plate. I later had to add a 1/4 inch steel plate to the top of this one because of the pressure issue I mentioned earlier. At 50 psi there is about 1 ton of pressure pushing on the ends of this filter housing. Even the steel plate blows out about 100 thousandths when I test it. Somehow I had left out that slightly important detail when I was drawing this thing up. boring another hole for a bulkhead fitting, this one in the cover. This is where the water will enter the filter and be sprayed onto the glass. This is the start of the collector manifold hub. The strainers, also known as laterals, will be attached to this in a radial pattern. After the water is filtered, it goes through this hub and then down through the bottom plate and out of the filter. I then thread it with a 3/4 inch pipe tap. If you're not familiar with National Pipe Thread taps or NPT taps, they are slightly tapered. That means that not only are you cutting a thread form, but you are also cutting in an increasingly larger diameter as you work the tap in. It can be a workout running one this size through metal. I'm glad this was PVC. Okay, here's the manifold we just got done drilling and tapping. It was set in there like that. We spun it, drilled it and tapped it, and using that pipe to hold it in the chuck. That's just a PVC Schedule 80 pipe. And here's the arrangement of strainers to go on it. Kind of looks like some sort of bug. And it sits like that. This part is another hub, but for the water inlet. The spray bars will be attached to this. There wasn't much space between the end of the spray bars and the inner diameter of the filter. I roughed them in here and got them all to the same size. Later I added plugs and then trimmed them to the finished diameter. Spray grooves are being cut here. They are added to distribute water evenly over the bed of crushed glass. These are PVC legs used to support the bottom of the filter. I am truing up the ends before I glue the mounting inserts into them. And these are the mounting inserts. Once I glue them in the legs, I will put the legs back in the lathe and finish the lengths.